past year, I worked with Professor Dewan and grad student Jacob Bartel on generating or predicting groups from email messages. So email is one of those prevalent forms of communication on the internet today. So we thought, what if we could make it easier to send emails to large groups of people without having to individually specify each user? So in the past, you guys might be familiar with the screen right here. Google has a similar approach to helping you predict who you want to send messages to. But the problem with that is it only predicts one user at a time, and it doesn't predict groups as a whole at once. So our approach is actually to analyze your past email messages to generate predetermined groups of recipients that you can send email messages to. And we're doing this by adapting a previous study that analyzed your Facebook account and created networks or groups of friends that you might want to, for example, send messages to together at once. And so this is the algorithm that we're using to generate groups. And you can see at the very top, it takes in a friend graph, and it finds maximal cliques, which are basically the largest sets of strongly connected components in the graph, and then uses that to generate groups that will be presented to the user. So the problem is that when you're using a social network, it's clear who, you have friends and you have people and they have friend connections, and so those are edges in the graph and the friends represent vertices. But it's more ambiguous when you have recipients in an email message because you don't exactly know the connections between each person. So we studied three different approaches here for generating that graph and determined which one is going to produce the most relevant groups to the user. So I'm going to go through here and describe each graph generation algorithm one by one. So the first way of creating the graph is to simply create a node for each person in a message and create an edge between every person in the current message and every other person in the message. So for example, you have three people. You create an edge, three people in the same message, so you create an edge between every person and every other two people in the same message. And the graph is unweighted. But one potential problem of this graph creation method is it doesn't take into account how old this message is. So for example, you're probably going to want to create groups that are more relevant to the past month or two than from like 2 years ago that you sent a message to. So this is where the second graph generation technique comes in. Simple threshold graph generation uses a threshold point before the latest message, after which to ignore messages. So say, for example, this is today, or the most recent send message, and then this is about a month. You go back, and then you create your groups based on this last month of messages, and you ignore everything that's too old. So here we have to decide what the threshold will be, and we chose to test with 1 hour up to 1 month before the most recent message. And one possible problem with that is there's no differentiation between whether a message was sent or received. So you probably want to give more emphasis or importance to a message that you send yourself, because you really want the computer to know that these people are more important than just when you passively receive a message. The third way we studied is using the Google scoring method, which is what Google uses to make predictions. And this involves taking the half-life of the message and also adds in a factor right here to give it extra emphasis, for example, if it was sent. And the advantage of that is that there's no solid cutoff point, but rather, as you go back to older messages, an increasingly less and less weight is given to that message. And of course, we have to figure out a point after which to drop edges when creating the unweighted graph run. So what we did to get data for our testing is run a study, and we collected data from 19 participants, mostly students in the department. And we collected up to 400 threads from each person, and from those up to 2,000 messages. So again, we varied the cutoff points. We decided that cutoff points of 1 hour to 1 day were completely irrelevant because just based on running it on my own groups, we're not producing any reasonable results. So we decided to test with 2 weeks, 1 month, and 2 months for this method. And of course, we had to decide what the half-life would be and the sin constant would be in order to use the Google scoring formula. So here, we collected data from, this is the data from all 19 people in the study, and this is the different edge weights. So on the x-axis, we have the data, which is actually just what would the weight of the graph would be. And on here, we have the cumulative probability, which as you go is kind of like a cumulative percentage of how many edges have that particular weight. And as we can see here, varying the sin constant from 1/16 all the way up to 16 times didn't really make a significant of a difference as we expected. And here we hold the sin constant to 1, and we change the half-lives, and we see a much more a greater distribution in the data. So at the very top here, we have the 1 hour and 1 day half-lives, and we can see either the method is, either the edge is created or not created. And as we go here, there's a greater variation in the weights. And so we decided it would be pretty reasonable to drop edges that are less than a quarter of, that have a score of less than a quarter, because they seem to be an elbow in the graph here that created a large difference. So as I said here, so the second part after we collected all the data and ran through it was how to evaluate which method was the best. And we did this by splitting the user data into 2 chunks. The first chunk is 80%, which we use to create the groups. So you can think of that as a training set. And the last 20%, we use that as a testing set and compare how well the predicted groups can be used in the testing messages. So the first metric that we used was group-centered evaluation metric. So basically what that means is for each group, we went through, for each predicted group, we went through each testing message, and we found the closest message that best matches this group. And then we got the minimum number of additions and deletions. So the goal here is to minimize this number right here of edits over the number of collaborators, because basically you're trying to see how much changes you have to make to the group to make it useful over the total number of collaborators in the group, because you don't want to use a group and then have to make more changes to it than it would have cost to just manually enter that yourself. And the opposite of this approach is to actually go through each message and see how close is the closest group on average. And you might be wondering why we would do that when we've already predicted the other way around. And it's because sometimes you may have too many groups generated by the algorithm, and that wouldn't be accounted for in the first metric. So here are some of the results that we got. In the green here were the best methods using both metrics. And in general, you have this column is generally going to have a lower average than this column, because it's easier for one group to fit a certain message than for a message to fit a particular group. And this is just a summary of the contributions I made, from writing the parser to adding support for Outlook accounts to developing the graph algorithms and the testing methods. And finally, I wanted to thank Professor Dewan and Jacob Bartel for working with me on the past year over this. It's really been great.